Let's take a look at a couple of these problems that I assigned last week. We'll start with number 39 on page 215. Okay. Um, this is a diving board problem. Wow, that was like a straight line. Okay. So basically it says we've got this diving board that is 1.5 meters long, or no, 3.5 meters long, sorry, and a person 85 kilograms is right here on one end. It's supported in the middle, and it's supported on this end. So we've got two supports, A and B. Okay, and then this diving board itself is not massless. It has a mass of 14 kilograms. Okay, so we've got to go ahead and label all our forces. First one I'm going to label is this one. This one's 85 times 9.8. Right, this is the weight of the diver, the force due to gravity acting on the diver pulling down. Next one I'm going to label is this one, the board. It acts right in the center since it's a uniform board, so that's 14 times 9.8. Okay, and then there's two other forces. There's the force that object or support B exerts, so this is FB, and there's the force that A exerts. This is FA. Okay, and then all we have is the conditions for equilibrium, which means the net force has to equal 0 and the net torque has to equal 0. So let's go ahead and find our net force. The net force, we have FA plus FB, those are added because I have them drawn in the same direction, minus 14 times 9.8, right, that one's down, minus 85 times 9.8 equals 0. Okay, and if we wanted to, we could go ahead and simplify that, and we have FA plus FB equals 970.2 newtons. Okay, but that's two unknowns, so now I've gone as far as I can go with that one, so I need to go ahead and take a look at my net torque. Okay, well, before I can do anything with torque, I need an axis of rotation. I'm going to pick B to be my axis of rotation. I'm doing that because the most forces act right there. B's unknown, this one I do know, but if I can eliminate those because their lever arm is 0, my life will be easier. So now I'm going to say, alright, my net torque is equal to 85 times 9.8 times that one's lever arm, which is half of 3.5, so 1.75. Now, this is causing a torque this way, and the way I have FA drawn, it's causing a torque this way. Those are both clockwise, so I'm going to have to add on the torque from FA. FA times 1.75 equals 0. Okay. Now, maybe some of you are seeing that my FA must be drawn backwards, but that's okay. We'll see what we get from it. Okay. So now I have 85 times 9.8 times 1.75 equals negative FA times 1.75, or FA times 1.75 equals negative, let's see, 9.8 times 85, 833 times 1.75. Okay. Since both of them are multiplied by 1.75, that goes away, and I have FA equals negative 833. Now what that means is FA is actually down, not up, because it has to balance this thing's torque. So FA equals 833 newtons down. Okay, and then I can put that into this equation. Okay, remember that's a negative then, so when it adds over here, FB is going to be bigger. So FB is 1803.2 newtons, and it's up. So FB has to exert a lot of force because it has to hold up the diver, it has to hold up the board, and it has to hold up this thing's force because it's pulling down in order to get the rotation to be 0. Okay, so that one's sort of a long problem, but it wasn't horrible. Okay, the next one I want to take a look at is number 103. Okay, and 103 was different because it had angles in it, but other than that, it's really not too horrible. Okay, we've got an object over here. Okay, there's my wall. I've got this long support here, and it's connected to a cable like this, and I think they tell us this is 25 degrees. Okay, and then let's see, we've got a flag over here, and the flag the banner weighs 105 newtons, so we don't even have to deal with mass. They're even giving us weight. 105 newtons. The pole is 2.1 meters long and weighs 175 newtons, so 175 newtons pulling down. And what is the tension in the cable? Alright, so this is simply a net force equals 0, net torque equals 0 problem. Okay, just like before. But we've got to deal with all the things that are going on there. Now, they went ahead and labeled this point right here as our axis of rotation, which is fine. Okay, but there's actually forces here, right? There's like a pin attached to the wall. So there's a force this way. Okay, that's the normal force the wall exerts, and there's a force this way. Okay, now I'm going to call this one FA and this one FB. Okay, now we'll see what happens to those in a minute, but for now I want the net force in Y. Okay, and the net force in Y is equal to FA minus 175 minus 105, right? Those are the two weights that pull down, and then there's this thing. Okay, now this is actually FT, or the tension in the cable, but it's pulling in two directions, right? It pulls up and over. So if this angle is 25, then this angle is 65. Okay, and so this I've got to add on to plus FT cosine 65, or sine 25 would be the same thing. Okay, and that equals 0. Alright, so I have FA plus FT cosine 65, which I'm actually going to get a number for. Cosine of 65 is 0.423 essentially, so plus 0.423 FT equals 280. Okay, right? I just added 105, 175 to the other side. Alright, so that's the net force in Y. Okay, now what can I do? We can go to net torque. Okay, and if we go to net torque, then what we can say is here's our axis of rotation, so net torque we have 175. Now the lever arm on that is half of the 2.1 meter pole, so that's 1.05. That's its lever arm, plus 105. And is that thing connected at the end? Nope, 1.8. 105 times 1.8 meters minus, and then the cable is connected at the end, FTY times 2.1. And the reason that it's minus is it's in the other direction, right? So now I have 175 times 1.05, which is 183.75, plus 105 times 1.8, which is 189, equals, and TY, again, it's the same side as we had before, so 0.423 TY, or just T, I guess, FT, times 2.1. Alright, we're almost done. Okay, so 183.75 plus 189 divided by 0.423 divided by 2.1, and I get FTY equals 419.6 newtons. Of course, that's not the tension in the cable, that's the tension in the Y direction. There's a couple different ways I can go about getting it back into this. I could either try the Pythagorean theorem and find x, or I can just use trig. Okay, if that's the Y side, then all I have to do is divide that by the cosine of 65, and we should get the hypotenuse, okay, which is 993-ish newtons. Alright, hopefully that takes care of a couple problems. If you have any other issues, let me know.